Hello everyone. Thank you for joining us today. I am Sravya Paluri and I'm interviewing my grandfather to record a video for the Heritage Center of IIT Madras. My grandfather served for IIT Madras for 36 years from 1960 to 1996. And he is none other than Professor YVGS Murti. And I'm very excited to hear about his journey on how his experiences were, how IIT campus was back then, and anything else he has to share. So thank you for joining us today.
Thank you, Sravya, for agreeing to conduct this oral history on behalf of the Heritage Center, IIT Madras. I am, as a teacher, more used to asking questions rather than answering. I hope you will give me some good marks for my answers today.
So I'll be asking you questions initially that are very general, related to IIT Madras, or in fact just IIT in general. So my first question is, what is the concept of IITs according to you?
The IITs are all institutes of learning. They are temples of knowledge. Such institutions are not built just from mere concrete structures, buildings or roads. They are built around an idea. It is the idea that is important. Swami Vivekananda said, you choose an idea before starting any new institution. Make that idea the idea of your life. Dream of it, live on it, live for it.
That's a beautiful answer, actually.
Okay.
What do you think is the idea of IIT Madras?
Yeah, thank you. The idea for IIT Madras we have chosen from Bhagavad Gita, chapter 4, verse number 12. The part of this verse, which is the motto of IIT Madras, is Siddhir Bhavati Karmaja. The literal meaning of this Siddhir Bhavati Karmaja is work produces success. Success is born out of work. Work engenders success. To get a full appreciation of this concept of work engendering success, I would like to repeat or tell you the whole verse. The verse goes like this. Kangshantaha karmanam siddhim yajanta yah devataha kshipram hi manushe loke siddhir bhavati karmaja. The essence of this verse is, the good Lord says, Krishna says, people worship gods with the hope of realizing the fruits of their labors as quickly as possible. But the fact is, it is the work which engenders success. Success is born out of work. That's what Lord Krishna says.
That is a very beautiful explanation.
Okay.
And I'm sure that next time when people look at the IIT Madras logo, they'll notice the motto written underneath the image.
Okay.
So there is another question that I've been curious since I grew up, spent my early days in IIT Madras. Who was the founder of IITs and how did all of this begin? I think I want to know more about that from you.
The founder is a Parsi gentleman. Ardeshis Dalal is his name. He was born in Mumbai, brought up in Mumbai, and went to Cambridge for doing ICS. ICS is the pre-independence version of IAS. After completing ICS, he came back to Bombay, worked as a collector for some time, then chief secretary of the government of Bombay State, essentially. Then he joined the Tata Group as director of Tata Steels. He worked in this Tata Group for 10 years, from 1941 to 51, at the end of which he was knighted. That he became Sir Ardeshir Dalal. Then this man was noticed by Viceroy himself. So he is invited to join the Executive Council of Viceroy. And the portfolio given to him was planning and development. So this gentleman, Sir Ardeshir Dalal, thought about what can I do for my country. India had already missed the industrial revolution. The state of industries in India is very poor because he has already known the industrial scene of India. He realized what we really need is engineers. For the growth of industry in India, we need engineers of high quality, high caliber engineers. So let us think of a way of producing engineers in India with high caliber, high quality, much like the MIT of America, Massachusetts Institute of Technology. We should produce engineers of high quality. That's what he decided. Then he constituted a committee of 22 members, chaired by Nalini Ranjan Sarkar, to thrash out this proposal, to bring out a proposal for starting such institutions across the country for turning out engineers of high quality. Now this committee deliberated whether to upgrade the existing engineering colleges or start new institutions. They finally arrived at the conclusion we need new institutions, new institutes, one in the north, one in the south, east and west, 4 such institutions to produce engineers of high quality of the MIT level. This is the report they submitted to the government. This all happened in 1946. After independence, this report was comfortably lying in the shelves of the Ministry of Education, gathering dust. It was at that time the Chief Minister of West Bengal, Dr. B.C. Roy. Dr. B.C. Roy was no ordinary Chief Minister. He is a go-getter Chief Minister. He will not wait for things to happen. He will make things happen. So he took action. He got hold of a copy of the Sarkar Committee report with the help of his friend Humayun Kabir, who is a powerful minister in the central cabinet. And that report he gave it to Professor J.C. Ghosh, who was then the director of IIT Bangalore. He succeeded C.V. Raman as the director. Dr. B.C. Roy requested Professor J.C. Ghosh to prepare a draft constitution for such institutions of high technology. Now we should all be thankful to Professor J.C. Ghosh because he prepared such a constitution that these institutes will be free from interference from the government. They will function as completely autonomous bodies. It is because of this constitution being framed like this that the institutes of IITs have grown to become centers of excellence, academic excellence. So this was how the first IIT at Kharagpur was born in 1951. It took 7 to 8 years for the next IIT to come up.
So, I think I already know that IIT Madras was started in 1959, which is actually roughly 1 year before you joined IIT. So, I'm very curious to know, like, when did you join, like, exactly, like, what was your background, like, how did this all happen back then?
Thank you. Before coming to that, I would like to make 2 things clear. Number 1, we are going to talk about things that happened some 66 years ago, about 2/3 of a century back. What all happened, we are talking about it now. So I hope my memory does justice to the facts and figures of those days. The second point I would like to mention is, when I joined, I was fresh from the university. I had not much of an experience professionally. So I also have grown along with the IIT as the years pass. So I had experienced the growth of this institute. I have witnessed the growth of the institute. So, and I also participated in the growth of the institute. So I am both an observer as well as a participant in this story. So whatever narration I am giving you of what happened so many years back is probably colored by this perspective, my own life, my own dreams, my own growth academic growth of it.
Yeah. So basically the question like I was asking you was like, what was the history of the institution? Like what was your background and all of that?
Now, the growth history of an institution like IITs usually has 3 phases. The first phase is the phase of primary growth, including genesis of the institution. In phase 2, the institution grows, overcoming hurdles and teething problems. The phase 3 is the phase where it has become an iconic institution already. I am going to talk mostly about the phase 1, less about the phase 2, and probably nothing about the phase 3.
I was also wondering like what was your background like before you joined IIT and everything?
Yeah. Okay, that's good. In a far-off village, obscure village, far from civilization, at the center of what is called Godavari Delta. It's the delta region of River Godavari. River Godavari originated at Triyambakam near Nashik, passed through several states, and at Rajamahendravaram, it splits it up into a number of branches. The land in between those branches is what is called the delta, Godavari Delta. My village is located at the center of gravity of this delta region. After doing the primary education, high school education, I had moved to Rajamahendravaram for college. That is one of the 2 colleges available in the entire district. So I joined a 2-year program of intermediate. It was called at that time intermediate in arts and sciences. You are taught number of subjects, including humanities as well as sciences. In those 2 years, it is expected you will formulate an aptitude and interest in one of those subjects. So after the 2-year intermediate program, I thought I will continue in a science stream and join a 2-year BSc course with physics as main, chemistry and mathematics as minor. After passing this 2-year BSc program for postgraduate studies, I went to Voltaire, Andhra University, Voltaire, same as Visakhapatnam. At Andhra University was offering several MSc physics courses, pure physics, applied physics, nuclear physics, geophysics including meteorology. I chose applied physics. It is a 3-year program. The first year we do only pure physics. Next 2 years we are taught engineering subjects such as electrical machines, motor generators, transformers, etc. and machine tools, all workshop machines, all hands-on experience, not merely the theory of working of this, hands-on experience, how to produce them, make them, how to run them, and electronics plus communications. So this learning part actually stood me in great stead when I started my own research career. In my experiments, this background helped me a lot. Now, after completing the course, I worked in the same department for 1 year as a demonstrator. It is at that time I was given the offer of technical assistant post in IIT Madras. Technical assistant is a misnomer. Actually, it's a teaching assistant. We are expected to help in running the practical classes and also probably some lectures. So after joining this, after getting selected, went to my village, seeking the blessings of my parents, and arrived at Madras, Chennai, what was at that time called Madras. After arriving in Madras, I went to the General Hospital in Raipeta to get a complete medical checkup. After medical checkup, I proceeded to go to the institute office, pass Adayar, landed in Sardar Patel Road. That Sardar Patel Road was completely deserted. Nobody is there to even find out the guidelines about how to reach IIT. They have not even heard of IIT because IIT was just born at that time. So the administration offices were held in CLRI, Central Leather Research Institute. Academic departments next door in AC College of Technology. Now physics department occupied one full bay, one bay. Bay means 10 feet wide about 30 to 40 feet long. At the rear end of this bay sits the head of the department, HOD. And there is a wooden screen separates the HOD from the rest of the staff.
I also was curious to know, like I want to know more about the staff, who was in the department, how was the department supported. I want to know all those stories that you want to share.
Oh, thank you. The rest of the staff means only the following. Apart from the HOD, there are 2 lecturers with PhDs. Dr. B.V. Murti with a PhD in X-ray crystallography from Allahabad University. Then Dr. B. Sivaramakrishnan had a PhD from Indian Institute of Science. Then other youngsters like me joined one by one as technical assistants. For the students, it was a 5-year BTech program molded on the pattern of German model. 1 week entirely they will have workshop classes, workshop practices. The next week theory classes. So workshop classes and theory classes alternate succeedingly. And the students are exposed to theory classes in the AC college building and highways department only. And as far as physics department is concerned, the theory lecture class was given entirely only by Professor W. Koch. You'd like to know about W. Koch?
Yeah, please. Yes.
W. Koch, Werner Koch is from West Germany. He came as a guest lecturer as part of the Indo-German agreement. He is a very nice gentleman. Professor Koch and Mrs. Koch, so also nice, they endeared themselves to one and all in the institute. Now, Professor Koch's lectures were very interesting, sometimes thrilling also. He followed the Pole School of Teaching Physics. What is Pole School of Teaching? The teacher does not go to the blackboard to begin with. He doesn't approach the blackboard at all. He conducts an experiment in which the entire class participates. How the teacher assembles all the items on the table and explains what he was going to do. There will be meters, ammeter, voltmeter, wattmeter, pressure meter and so on, whatever meters are required. And these meters have transparent scales. The pointer moving and that, these meter scales are projected by means of arc lamps to a screen. So everybody, entire class, anybody in the class can read the pointer readings. The pointer moves. As the experiment progresses, the pointer readings will change. They will be all able to note down the readings of all the instruments. When the experiment is over, only then the teacher approaches the blackboard to summarize and draw up the conclusions. This is done for every chapter. It begins with an experiment. Then only the rest follows. This is a very good method, which is not done in the British model at all. What we have been exposed to in earlier classes. Now in this method, what is emphasized is physics is born out of experiments. That point is well taken here. Professor Koch's lectures were very good. We, the younger staff, helped him conduct demonstration experiments. The physics of the courses, of course, are very basic, and advanced level topics were covered later by us. Professor Ramashastri urged all of us to attend his lectures because they are very instructive. Giving the example of the Pohl's model, R.W. Pohl's model of teaching physics. And then Professor Ramashastri was unhappy. Teaching is okay, but what about research? He was very unhappy. There is nothing else being done for research.
I'm curious actually a little bit more about Dr. Ramashastri's background. Do you want to talk more about him?
Yeah, sure, I will do that. Dr. Ramashastri did his doctoral research at Andhra University, working on the spectroscopy of diatomic molecules. And he got a DSc degree, DSc, Doctor of Science. It is somewhat higher than the PhD levels. After getting his DSc degree from Andhra University, he joined IIT Kharagpur, the new institute just come up already, as a lecturer. While he was working there as a lecturer, he got an offer of a postdoctoral fellowship from the University of Illinois, Urbana-Champaign, to work in the group of no less than a person than John Bardeen. John Bardeen was a very famous physicist who got 2 Nobel Prizes in physics. The first was for the discovery of transistor. The second was for producing a theory for superconductivity. Now Ram Shastri joined this group and worked on semiconductors, self-diffusion in silicon crystals, published papers. Then when he came back to IIT Kharagpur, he started a school of research in semiconductors. It was then at that point of time, IIT Madras offered him an assistant professor's post, and the founder had a department. They wanted him to develop the School of Physics, Department of Physics at that time.
That is a very beautiful journey to know more about him. So thank you, Professor, for answering that question as well. Before we move forward, I have always been curious. I know you have been very passionate about physics for as long as I've known. But I've always wondered, like, back then, how were the teachers and how were the families of the teachers, how were they housed? So do you have anything to tell us, like, so that we go back in time?
Sure, not much, but whatever I can remember from those days, I'm actually reliving that life now. When I'm narrating these stories, most of us stayed in nearby leased apartments. I joined Dr. Ramana Murti's family in Mandavelli Pakam. Dr. Sivaramakrishnan and family were in Mandavelli. The rest of them were living in Adayar, and all in leased apartments. And we used to come to the departments via city transport buses. The students were housed in makeshift hostels in Saidapet. They used to come to the classes by bicycles. Bicycles.
Yeah. So thank you for answering that question as well. I wanted to actually go back to Professor Rama Shastri and know more about what he had to offer as well.
Yeah, we'll continue that thread about Rama Shastri. He was unhappy with the fact that we are not talking anything about research. So he wanted to start a school of research. Just like B.C. Rai was eager, could not wait for the IIT to come up, he was not willing to wait for the school of research to start. So a number of crates, boxes have come from West Germany, unopened. So we'd like to know what is contained in those boxes. There may be research equipment, research instruments, measuring instruments, tools for research, anything may be there, we don't know. So Rama Shastri wanted those crates to be opened. But Professor Koch was averse to it, because he said there's so much dust around. If you open the boxes, instruments, everything will get spoiled, the damage. So he was not willing to have the crates open until we have dust-free rooms, air-conditioned rooms ready. Now,
yeah, sorry. So I have a question there as well. So I know you're taking us back to an IIT Madras that had a lot of dust in some of the rooms present. So I'm now actually very curious, which was the first academic building that was constructed, and if you want to take us back in time on how the buildings look like inside the campus.
Yeah, sure. The first academic building came up in 1962, if I'm right. The building was Building Sciences Block. It's called BSB. That was the first name. So as soon as this building was ready, the physics department was the first to shift to this first floor, occupied the first floor of the rear wing of this building. The front wing upstairs we used for practical classes. So we used to come to the departments, starting from the in-gate, that's from the Dr. Sardar Patel Road. From the in-gate, we trekked the Bharat Forest Road, Kacha roads. The roads are not ready yet. Then sometimes we asked the administration to send us a jeep. The administration said, "No jeep, you are young, you can walk," they said. And we walked out of the department. So the building is ready now. So Professor Ram Shastri somehow persuaded the administration to get 2 small rooms in the ground floor, air conditioned, and told Professor Cook, my rooms are ready, shall we open the boxes? Somehow, with reluctance, Professor Cook agreed to it. We opened the boxes. What did we find? We found a lot of equipment, lots and lots of equipment, all for demonstration experiments only, all for used by Professor Cook in his lecture classes for demonstration, all teaching aids, nothing for research at all. No research instrument, no research equipment, no tools, no machines, nothing like that. So Professor Ram Shastri was hugely disappointed. The rest of us also very unhappy. In fact, I was also very unhappy because my dream was to do science research. I have a job so that I can supplement the income of my father, who is almost retiring, and also pursue my dream of doing science research.
Yeah.
That dream also is gone.
Understandably. Yeah.
But Professor Ram Shastri is not one to be discouraged. Just like that. So he was young. He was in the mid-30s. That is, energetic, bigger, and not willing to take the situation as it occurred. So he devised a plan to pursue research. He didn't have equipments, resources, etc., but he did have human resources in the form of young fellows willing to do work, willing to work hard and pursue science career. So at that time, the neighboring campus, Madras University Physics Department, was doing nuclear physics and theoretical physics. Professor Ram Shastri's background was spectroscopy. He did basically spectroscopy of molecules. So now he decided spectroscopy is the subject was in the waning phase. People are turning more and more towards the physics of solid state, condensed matter state. So he decided, let us do condensed matter state, condensed matter physics, which was called at that time solid state physics. Both are the same thing. So we started thinking about solid state physics research, condensed matter physics research. Condensed matter means many things. There are many areas. Professor Ram Shastri chose such areas which we can tackle with limited resources at our disposal. So these areas are ion transport, color centers, radiation damage, magnetic resonance, and semiconductor surface states. Towards the pursuit of these areas, Professor Ram Shastri asked us to study these areas. The 4 or 5 assistants were there, individually allotted the topics, and come up with a research level seminar, give a seminar lecture. So we will get prepared to work at a high level, at the MIT level, to pursue research in these areas. I led the semiconductor seminar activity by talking about crystals and tensors. In this context, I should refer to a book which was published not many years before, edited by W. Shockley. He was the co-Nobel laureate of transistor discovery, on imperfections in nearly perfect crystals, published in 1952. He highlighted the importance of imperfections because of the background in semiconductor technology. The doping produces imperfections, and these imperfections play a very relevant role in the device performance. So we thought we'll focus on imperfections, crystal imperfections. What are crystal imperfections? You know, in ordered solids, the atoms are arranged regularly in an ordered manner around a crystal lattice, 3-dimensional lattice. Now, in reality, no crystal is perfect. Not all the atoms obey the rules of the lattice order. So if you, for example, visit a million lattice sites, you may find 1 or 2 lattice sites empty. So such sites are called vacancies. Or sometimes you will find the wrong atom. That is an impurity. Or sometimes you find a right atom, the atom, in a wrong place. That's called interstitials. These are all examples, simple examples of crystal imperfections. Crystal imperfections play a dominant role in shaping the properties, physical properties of crystals. Now, we are targeting this set of crystal imperfections in our research experiments. How do we do that? For example, crystals as they grow, they're very transparent and sparkling. But sometimes they are also colored, they acquire color. Then they are said to contain color centers or F centers. The problem here is we may color them or not color, find them in color state. Problem is to find out what is responsible for the color. What are these so-called color centers? What is the nature, what is the identity of these crystal imperfections? That is one research problem. Then if you come to the radiation damage, if a crystal is exposed to energetic radiations like X-rays or gamma rays, the crystal gets damaged. The ordered solid may now be disordered with the chaotic locations of the atoms. For that, the atoms must be pushed away from their normal minimum energy sites. So when a photon, an X-ray photon or a gamma photon is incident on the crystal, can it do this damage? For that, you look at the energy required to dislodge an atom from its lattice site is of the order of 20 to 25 electron volts. Whereas the photon, X-ray photon, has an energy of kilo electron volts, quite much higher than required. And gamma ray photon also has a very high energy, a million electron volts. So they have enough energy, all right, but they will not be able to dislodge an atom from its lattice site because they cannot transfer the momentum. Example is, imagine a steel sphere sitting somewhere on the table, and a ping pong ball comes and hits it with high speed and hits it. When the ping pong ball makes a direct hit on the steel ball, nothing happens to the steel ball, hardly moves, doesn't budge. What happens to ping pong is a different thing. So here the ping pong ball is not able to transfer momentum so that the steel ball can shift, can move. Same thing happens here. So then, it's a fact that the damage does occur, atoms get dislodged. Why or how? So what is the mechanism that accomplishes this result is another problem, research problem. We have to do, find out, investigate. Like a detective investigating a crime based on the clues available to him. He will judge who has done it, like that. In the same manner, we use clues of the optical spectra, magnetic resonance, and sometimes charge transport to investigate these crystals with imperfections to find out the nature or identity of the crystal imperfection. So that's a very thrilling, interesting and challenging task.
Thank you for actually telling us. These are very interesting things. I've never thought about crystals in this way that you have shown us today. I'm also very curious now that you have told us like these are the kind of defects that can happen. This is the parameters by which you also investigate these problems. I'm very curious to know like how did you actually solve this mystery? Like did you have to build any research tools to actually investigate the problem or solve the problem rather?
Good. You asked me questions which are the very questions we ask ourselves at the time of doing the experiments to answer the questions about the identity of crystal imperfections. We need clues or data. More clues, we'll be nearer to the truth in our analysis of the results. So we need to probe the crystals to get response from the crystals. That will give us information about the nature of the crystal imperfection. So there are several tasks involved before arriving at this situation. Number one, we should be able to grow single crystals. See, most materials, they're said to be crystalline but most materials are polycrystalline. They are not single crystals. It's better to grow a single crystal so to avoid grain boundary effects that's present in polycrystalline material, powders. So to grow a single crystal, there are several methods, either for aqueous solutions or from melt. We mastered the relevant techniques, Bridgman technique, Czochralski technique, to grow single crystals in as pure as a form as possible. Then, in order to probe, what we do is we dope the material, the crystal, with impurities, deliberately adding impurities. So the addition of impurities such as multivalent impurities will alter the crystal imperfection statistics in the crystal. So from that we'll get information about the nature of the defects. So we have to learn the task of not only growing single crystals, but also to dope the crystals with chosen impurities. That's apart, we need to work with materials as pure as possible to begin with. So purification is a necessary first step. So towards that end, we constructed a setup, an apparatus called zone refining apparatus. This zone refining decreases the impurity content from ppm level to lower levels. ppm means parts per billion. If there are a million atoms, one atom may be wrong impurity level. So to increase the degree of purity, we use the zone refining apparatus, all constructed by me. And for the growth, as well as for subsequent measurements, we need furnaces to raise the temperature. So I myself wound the tubular muffle furnaces using nichrome wire and insulating material like asbestos and wool, etc. That is another part of the story. Then for make measurements of the conductivity, electrical conductivity, these crystals are low conducting materials. They are very poor electrical conductors, almost insulators. So if you apply battery voltage to the crystal, very little current flows through it. But if you increase the temperature, more current can flow. To measure this current, free from extraneous effects, that is to obviate surface leakage currents and spurious currents, measure only the crystal current, we developed a measuring setup specifically designed to achieve this task. So these are some of the tasks we have carried out toward the end of detecting the nature of the crystal imperfection, the crystal, by various means. Electrical conductivity, optical absorption, magnetic resonance. These are all the other tools that are combined to arrive at the truth of this.
I have an interesting follow-up question for you.
Okay.
So you talked a lot about how you build this apparatus on your own and everything. So I'm very curious to hear, how did you manage to get a hold of all these materials? Were they readily available or did you struggle? Like, I want to know your story.
Thank you. That's a very relevant question which we faced at that time, because none of these things are available in the commercial market. You can't get furnaces, you can't get anything. So some of the components and materials are not available in the market. So I used to make trips to what was called Moore Market in the city of Madras, close to the central station, and on the Nangambakam High Road. There's a big complex of shops. The shops selling used items. Whatever, the good or bad, all kinds of materials. I used to make trips to that complex to find out if there is anything there which may be useful to me in my apparatus, my setup. So that was very, very profitable way of getting things done.
Actually, I now want to go back to another question. So speaking of materials, I was wondering, you left us at a cliffhanger in the beginning of the beginning of the interview when you told us about the crates that came from Germany. You told that they had only teaching material I'm curious to know why that actually happened.
That's good.
Why were there no research-related materials?
That is a very relevant question, which is worth pondering over. In fact, this question has been analyzed by a professor of history of science, one called Professor Ronald Witze. He's a professor of history of science. He got a PhD in history of science from Norway. He is a German. He tackled this question of what is called Indo-German entanglement in science and technology, specific reference to Indian Institute of Technology, Madras. The reason was, according to him, which is also obvious, even according to me, is lack of communication between the German planners and the Indian side. The German end, they thought that they were going to help a low-level engineering college, not an MIT level engineering institution, as conceived by Ardesh Dalal or Sarkar Chandri, not at all. So that is why they supplied only the teaching material, and professors were good at that task only. And we did not receive research materials as a part of the first Indo-German agreement. That came to a halt in 1964 itself. And the next Indo-German agreement, it was yet to take shape. We already passed, as far as by our own experience, we already passed phase 1 and almost coming in phase 2.
Yeah, thank you for that answer. It is very sad to see how IIT Madras, or rather India, was underestimated as to what we could achieve with the materials provided. So now I actually want to come back. Like, we have come so far from then. Do you think that do you have any information on you or your group succeeding in getting noticed internationally? I would love to know what happened after that.
Yeah, the internationally getting noticed is a very important point. That gives you confidence that we have arrived, we are on the boat of this research path. We published a number of papers in reputed international journals, attended conferences, national as well as international. So we were really noticed. In fact, the fact is, any scientist visiting India made it a point to come to Madras and visit our solid state labs and make discussions with us. So there is a stream of editors from time to time. Regularly they are visiting us. Our group was recognized as a group with doing good work, internationally accepted, acclaimed work. So prominent among them are Dr. A.B. Lydiard. He is the head of theoretical physics division of atomic energy establishment of Harwell, England. England. He was one of those. And then another Professor R.J. Freehoff from the University of Brown University in America, and from J.C. Brown, F.C. Brown from America again, M.J. Norgate from Atomic Energy Establishment, and Dr. Clemson from Clemson University. Like that, we have had, and F. Benier from University of France. Like that, there are many such eminent scientists did visit us. From time to time, had discussions with us. And as a probably consequence of these visits, I was given an invitation to attend a 3-month workshop in solid state physics at the center called International Center for Theoretical Physics at Trieste, Italy. The director of this center was no less than Salam, Abdul Salam, is a Pakistani. He later got a Nobel Prize for his work on unification. He was the director of that center. He instituted that center. So I spent 3 months of my time there talking to him. So that was a very interesting, useful, fruitful interaction. Not only we listen to others speaking, we also can project our own experiment. So the outcome of this 3 months interaction was that we gain more confidence in what we are doing. We are second to none in the world in solid state research. So that's the feeling. At the end of this workshop, I was invited by Dr. Lydiard to visit ARE Orwell. Spend some time, as much time as you want, you can visit, he said that. I was using their IBM 360 system also in the process. These are some of the recognitions we received thankfully.
Thank you for that answer. Now that we have heard about how IIT Madras professors got the chance to go abroad and attend many international conferences, I'm curious to know, like, did IIT Madras conduct any conference that you remember?
Yeah, I'll presently come to that.
Yeah.
In continuation my previous answer,
Okay.
I would like, because the remark you made about India, how it is noticed now, I would like to supplement that by saying, in those days, that is when we were in the independence, post-independence, India is regarded as one of the third world countries. Third world, they call third world countries. Later on they call it underdeveloped countries. See, the naming has changed from third world to underdeveloped countries. They thought it's insulting, they changed it to developing countries. So that was the label we are given as developing countries. That's not bad. So when I visited this Trieste Center, interacted with so many scientists from different parts of the world, at the end of it, they told me, the senior scientists told me, India is not a developing country. India is a developed country. He realized the way I was interacting with others, quite a shock, because we are used to using questions. So they realized that India cannot be underrated, as you mentioned.
Yeah.
They said India is a developed country. This was as early as 1970. He said. So that itself speaks volumes. Not only we gain more confidence, self-confidence. So the Atma Nirbhar slogan, we could have raised even at that time.
Right, yes.
We built everything ourselves, without any collaboration from an advanced country like Germany. This is not their fault. This is a question of mismatch in the understanding of the way of what institution they are trying to.
Okay.
Thank you.
So going back to my question, I wanted to know, did IIT Madras organize any conferences?
Yeah. In 1975, we did organize an international conference on defects in non-metallic materials, in which scientists from various countries participated. UK, France, and USA, all these things. And also we conducted an Indo-German advanced seminar in solid state physics, for which I was the secretary. Apart from, I was secretary also for the conference, for which Dr. Ramshastri is the chairman. 3 other professors, including me, were secretaries, assigned different tasks. I was in charge of conducting the advanced seminar on solid state physics, in which a number of experts participated, not only from India, also from Germany. This is not part of the second Indo-German program. This is a different effort.
I'm curious actually if there was any prominent person that you remember who visited IIT Madras that you would want to talk about today.
That was a good thing. It was an honor to ourselves. Dr. John Bardeen, the recipient of 2 Nobel Prizes in physics, and in whose lab Dr. Ramashastri worked.
Yes, yeah.
As a postdoctoral research scholar. He was invited by IIT Madras to receive an honorary doctorate, honorary doctor causa they call it, from IIT Madras. We honored him by giving him an honorary doctorate degree, John Bardeen. So that was a thing, we are pleased to do it. It's not as if he in need of honors. He received many, many honors. We were part of those a gang of people honoring him.
That's a wonderful answer. Thank you for telling us that as well. I was wondering if you want to highlight anything about like what we received from Germany, because I know Germany played an important role in developing IIT Madras. Is there anything else you would like to add here?
Yeah, thank you. I think it's necessary for us to acknowledge whatever help we received from many quarters, notably from West Germany. Germany. This happened as part of the so-called Second Indo-German Agreement, as a result of which we did receive equipment, research equipment, costly, sophisticated equipment of the following types. Number one, we received liquid helium plant, which was a very important addition to a physics research labs. We also received microwave equipment. Then we received a Carry 14 infrared visible ultraviolet spectrophotometer, and then an ESR spectrometer, magnetic resonance spectrometer, for two bands, X band as well as Q band. That's a very unusual thing. So, and an X-ray diffractometer. So these equipments were used subsequently by other faculty members, newer members and others as well as and when they required. So this is something which is good, even though it happened at the very end of phase 3, and it is not part of what I mentioned as phase 1 and phase 2.
Okay, thank you for answering my questions, and we are also very grateful to Germany to provide us with all these equipment that helped us advance science research in physics department back then. My next question is a little bit about you. We have not talked a lot about your work and your contribution. So to begin with, I just wanted to know about the topics of your research and what you think is worth highlighting here as well. So please go ahead and answer.
Good, thank you. I will be very brief. From the start, from day number 1, I have been associated with these research programs in the so-called solid-state physics laboratories of physics department. I was closely associated with the work going on a day-to-day basis. And Professor Ramshastri, as the leader of the group, he was discussing with me all experiments, the findings of all experiments, not only my experiments, but all other experiments, so that I am thoroughly familiar with all what has been happening here. So it was a great opportunity for me to learn so many things, both in association with Ramshastri as well as with others. As far as my own contribution is concerned, after getting my PhD degree, I was started helping other doctoral students in various areas. Again in solid state, but prominently, there are two major areas which I have developed subsequent as postdoctoral effort. These two areas are, number one, nonlinear optical property, nonlinear optics, optical nonlinearities. It is my fortune that I have been associated with the research programs of the physics department, especially in the solid-state physics labs. From the very start, I have been associated, so that I am familiar with what all has happened on a day-to-day basis. So Professor Ramshastri used to consult me, even though I am at a junior level, and at every stage. So I am familiar with every area of solid-state physics research labs there. That was a fortunate circumstance for me. After my PhD, I trained a number of students, as many as 20 students for PhD programs in two broad areas. Both areas developed by me only, not as part of this solid-state physics labs steered by Professor Ramshastri. These areas are nonlinear optics. Second is theory of point effects. Crystal imperfections we talked about, all that we talked about from an experimental point of view. Now theory of point effects is a theoretical point of view. We don't do any experiments at all. We don't touch it, screws and bolts, etc. But we deduce things which are of importance. In nonlinear optics, the behavioral materials. But for example, I want to tell you, suppose you take a glass piece and send a beam of green light and a beam of red light. Both of them pass through the transparent glass piece. Nothing happens to green or red light. They ignore each other. There will be no interaction, no mixing between the two rays. That is the usual linear response of materials. If the material is a non-linear material, it is possible for there is energy to flow from green light to red light or vice versa, as the case may be. So that's called wave mixing. So this is called non-linear wave mixing. If the material has a non-linear response, it is possible For example, if you use an infrared wave, if it's a nonlinear crystal, it will generate a visible laser. So that is one method of producing second harmonics, third harmonics. This is called nonlinear wave mixing. We performed a number of experiments with 4 waves, not 2 waves. 4 wave mixing we say. And a special effect called optical phase conjugation. We did a number of experiments with a number of types of materials. And then the other area I developed is theory of point effects. In the theory of point effects, we talked about crystal imperfections. Crystal imperfections not only which you are adding, all crystals, every crystal has an intrinsic concentration of defects for thermodynamic reasons. More defects means more entropy, more disorder. So nature prefers more disorder. Entropy goes on increasing, no? So we can, that depends on what is called the thermodynamic parameters of the defects. So called enthalpies of formation, migration, etc. So we use theory, we develop theories to calculate these quantities from first principles. So in that process, we introduce a number of innovative methods, models for describing what is called the dielectric response of materials more truthfully, more accurately, so that we will be able to predict the thermodynamic enthalpies, etc. of point effects. Okay. This was very successful. In fact, one French scientist recorded in one of his papers that our calculations, our theory is the best amongst the world. And because of these innovations we introduced from time to time, improving the level of physics in the modeling, what's called modeling of these point effects. I was invited to give a keynote talk at an international conference held in Germany in the early 90s or so. So that is another recognition. We talk about recognitions, etc. Of course, I was quite active in the domestic scene among for all international seminars, etc. Also a member of this sort of all that I'm not mentioning. Thank you.
Also, I want to remind you that you have also published a book with Professor C. Vijayan on the physics of nonlinear optics, published by Springer Nature. Now I'm just making a personal touch to this and asking you, like, I know this was your journey in IIT Madras. I want to ask you or make you comment on how you continued this journey on physics in IIT Guwahati as well. So please share your thoughts.
Thank you. My journey beyond IIT Madras was more of administrative rather than academic. So after superannuation at IIT Madras in 1996, I had 2 paths to take. Number one, I was awarded a fellowship from CSIR where they give me honorarium for 5 years with project donation for equipment, staff, etc. for 5 years. It's a project. It's a rare project, they don't give it to easily. And then the other option was to join IIT Guwahati. They sent me an invitation, asked me to come there and start the physics department as a founder, head of the department. I was the first head of the department at IIT Guwahati, Department of Physics. So immediately the next day, I went to IIT Guwahati, joined as head of the department, professor in the department of IIT Guwahati. My task was there to develop the department from scratch, almost like my stay in IIT Madras. But here as head of the department, I was starting it, recruiting faculty for various cadres and developing the teaching and research laboratories. I had the help of younger faculty members there. They worked nicely so that we developed the teaching labs and research labs. Buying equipment. Money was not short supply. A lot of money was there. Unlike in the case of Madras, so much money is there, only there is not enough people to spend the money. Because there is spending money means there is a process. So to go through the process, we need hands. We are short of hands to spend money at IIT Guwahati, but we manage to spend as much as possible and acquire equipment to start labs. So we stayed only for 3 years. In the 3 years, this is what I had done at IIT Guwahati. Of course, I continued I had a project sanctioned by DST on theoretical physics modeling, which is called Mudra. That is, whatever models we said, no, we can make it into a package, user-friendly package. So anybody would like to know, calculate the thermodynamic properties of the point effects, they can use it very easily and get the answers. So this package was sanctioned by, this project was sanctioned by DST earlier. So I could not start it because there was no time. So I asked them whether I can do it at IIT Guwahati. They agreed. So I started that project in IIT Guwahati along with another person who continued running the project after my exit from there. Then of course I did another thing I remember now. Is during my time there, I started what is called a Northeast Academy of Physics Academy for Northeast. So this is an academy I founded with the help of 2 vice chancellors of Assam, in which the idea was to bring together all scientists in physics on a single platform, and we got money also from GST and SSR to help their expenses. So this is another thing I achieved there. It is still running nicely now, that academy. And of course, other small things I did there, they are not worth mentioning now. So that is all. Thank you.
I also wanted to ask you an interesting question. So I wanted to address the elephant in the room, which is your thesis, which was written in IIT Madras, because that's where you did your PhD. So I was curious to know which year was this thesis made?
Oh, it was made in 1966. And it so happened, I would say, that is the first PhD thesis based on work done at IIT Madras. So the first PhD here. There are others who received it, but work done elsewhere, they somehow got a degree from IIT Madras. So in the respect that in terms of the work done at IIT Madras, the first PhD thesis.
Wow.
In my reckoning, some people can dispute it because they have got they produce the work, they produce the degree after doing the work elsewhere. They come here and then
published it. Yeah.
So that's not very important that question.
Okay.
So in that respect, from the physics department, this is the first PhD thesis to be submitted.
That's great.
Submitted. That will take care of it.
And I know today you talked a little bit about the apparatuses that you have built during your PhD time. Would you like to show me in your thesis? I would love to see it.
Yeah, there is one zone refining apparatus, which may be of interest.
Okay.
Because I built it by my own hand, right from the scratch. So it worked. So the zone refining is a very important process for materials processing. Even silicon, we get all chips. They're all single crystal chips. They are all cut from single crystal. After purification, before any N-type or P-type chip is prepared, first we started ingot, silicon, which contains all kinds of impurities. They purify it, and finally they use the zone refining or float zone technique. What happens? The ingot is molten in some region, so it forms a shape like this. Because of surface tension, it remains in place. So in this process, from liquid phase to solid phase, there is a segregation of impurities. More depending on the solubility level of the impurity in either liquid or solid phase, as the molten zone passes, there will be separation of impurities. More and more impurities may go into the solid phase, less into the liquid phase. You perform number of passes. After number of passes, a good degree, high degree of purity level is achieved. Then they dope it. They cannot dope as of the available ingot. After achieving a lot of high degree of purity, then they add N-type impurities or P-type impurities. So the zone refining, even today, that is how it is. Single crystals are grown somewhere. They also do the zone refining. and then add N-type or P-type depending on what they are going to sell in the market. So that in those days it was new to us. Now it is done as a matter of routine. But okay.
We really appreciate hearing all the stories you're sharing. So I just want to make a comment on how, from what you have answered, like how important funding research is, whether it comes from Germany or whether it comes from DST or other internal funding agencies. We are very grateful to the funding we get for research.
Okay.
Because without that, we cannot conduct any experiments.
Correct.
So we are grateful for that. And also that brings us to, that was the last question. So thank you for answering all the questions. And I want to also comment on that, how much I have learned today about your academic life. We found out, like in IIT Madras to begin with, how the situation of IIT Madras was 66 years ago, and how through the years all these prominent people who either visited or were professors or faculty who contributed immensely to the growth of research in physics department and in other departments as well. So we have learnt a lot, and we also learnt about the different topics of research that you conducted as well as your colleagues conducted. So we are very grateful to you, and we are also very grateful to the Heritage Center of IIT Madras for giving us the chance to contribute all the journey you have had through your eyes and to be archived into this center as well. So thank you very much, and I would like you to speak the last few words as well.
My last few words only thank you.
Thank you very much.